Good morning, students. Welcome to online class. Today I am going to explain the introduction part continues. Yesterday I already gave the mean and median in ungrouped data and grouped data formulas. Today the continuous part, cumulative frequency curves. And these cumulative frequency curves are also called as ogive curves. Ogive curves given or cumulative frequency curves is given. If the cumulative frequencies are plotted against the upper or lower boundaries of the corresponding class intervals and joined them with a smooth curve. Then these curves are called ogive curves. These are two types. The first one is less than cumulative frequency curve or less than type ogive. The second one is greater than cumulative frequency curve or more than type ogive. These are the most important graph. It is very important in second paper 2. Mostly it was given less than type ogive curve or greater than type ogive curve or draw ogive curves. Okay. Uh, what is the less than ogive curve? The upper boundaries of the classes are taken on x-axis. X-axis and corresponding less than cumulative frequencies are taken on y-axis, and these points are plotted with smooth curves. Is called less than type ogive. Next, more than type ogive. Greater than ogive. The lower boundaries of a particular class are taken on x-axis and corresponding greater than cumulative frequencies are taken on y-axis, and the points plotted with and joined with a smooth curve is called greater than cumulative frequency curve, or greater than ogive curve, or more than type ogive curve. These two are this is the less than type ogive. Upper boundaries less than cumulative frequencies, and another one is lower boundaries greater than cumulative frequencies. This is like this. The graphs are like that. Okay. less than type OSU curve is a rising curve. From 0 onwards, it is rising. Greater than or more than type OSU is a falling curve. From 0 onwards, it is falling down. It is rising, that is down. Less than is rising, greater than is falling. Okay. Determine the median from the OSU. How to find the median from these OSU curves? Sometimes it is also asking. From n/2th observation, draw a line parallel to x-axis cutting the curve at a point and from that point to draw a perpendicular line to intersect x-axis at a point which is median. For example, here 100 frequency is there, n/2 means 50. For example, 10, 20, 30, 40, 50 is there. Draw the parallel line to x-axis. Parallel to x-axis. It is intersect the less than type curve here and draw one perpendicular line that point here. From that point, that is perpendicular line. So where it is cut here, that point is a median of that value. For example, here 10, 20, 30, 40, 50, 60, 70 like that. It is nearly 50 to 60 is there. 52, 53 something you write. That is the median. So if you use the formula and use the graph, the median value is same. Approximately a small changes is there. Okay. This is the median finding by using curves. OSU curves. Next, determine the median from both OSU curves. How to find the median from both OGU curves? Less than OGU curve and greater than OGU curves, intersect at a point from that point to draw a perpendicular line to x-axis to intersect x-axis at a point, which is the median. For example, this is the less than type OGU and this is the greater than OGU. These two curves intersect at a point here. That point, from that point you draw one perpendicular line to x-axis which is intersect at a point. This point is called median. That determine the median from both the OGU curves. Okay. Next, the third one. First one is mean computed, median computed. Now the third one is mode Z. Mode is the occurring the most mode is the occurring most of the observations. Is called a mode. For example, 1, 2, 3, 4, 1, 5, 9, 6, 5, 3, 2, 5, 6, 5, 7, 8, 9. Here, one number is occurring most of the time. For example, here 1, 2 times only. 2, 1 times, 2 times, 2 times. 3, 1 times, 2 times, 2 times. 4, only 1 time. 5, 1 times, 2 times, 3 times, 4 times. And 6, 1, 2 times. 7, 1 time. 8, 1 time. 9, 2 times. So, which number is most times came? 5. 5 is the 4 times. Most frequently occurring. So, mode equals to 5. Which number is using more time? That number is called mode. If data have only one mode is called unimodal. It has only one mode. One number is most frequently occurring. So here one mode is there. That mode is called unimodal. Sometimes two modes came. For example, 5 4 times, 6 also came 4 times. So 5 and 6 are the mode. So 2 times came. So if data having two modes is called bimodal. That is bimodal. If the data having three modes is called trimodal. If the data having mode may or may not. Sometimes no mode is came. For examples, find the mode of natural numbers. Natural numbers means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. What is the mode? 1 came one time, 2 came one time, 3 came one time, 4 came one time. If any number came only one times. So here there is no mode. So the data having mode may or may not. Is it there or not there? Mode of first n natural numbers. Does not exist. This is very important formula for our examination point of view. Mode z equals to L plus f0 minus f1 by 2 f1 minus f0 by 2 f1 minus f0 minus f2 into h. L plus f1 minus f0 by 2 f1 minus f0 minus f2 into h. This is the very important formula where L equals to lower boundary of model class. What about F1. F1 equals to frequency of model class. F0 equals to frequency of class preceding the model class. F2 equals to frequency of class succeeding the model class. L, F1, F0, F2, H. Size of the class. Size of the model class. These are the very important three measures of central tendency. The next very important is range. How to find the range of the given data? Thank you, students. Tomorrow discuss about the range.